Hello everyone, welcome back to the channel. My name is Dev, and if you are studying data science, machine learning, MCA or MTech, then today's video is going to be super helpful for you. We are going to break down most important 10 topics from data science assignment in a simple, clear and easy to understand way. These topics are very important for exams, interviews and practical ML application. So let's jump right in. So our first question is ask us to explain the difference between supervised and unsupervised learning. So first, supervised learning. This type of learning uses labeled data, meaning both data inputs and outputs are known. This model learns the mapping between them. The examples of supervised learning are linear regression, logistic regression, random forest, SVM. Its uses are spam detection, diseases prediction, email classification, salary prediction, etc. Now let's look unsupervised learning. Un- in unsupervised learning, the data has no labels. These models try to discover hidden patterns or groupings. The examples of unsupervised learning are k-means in hierarchical clustering, in PCA and in TSNE. Its uses in customer segmentation, anomaly detection, in market basket analysis, etc. In simple terms, supervised equal to learning with answers and unsupervised equal to learning patterns without answers. So this is all about question number 1. Now let's talk about the question number 2, which is the hypothesis space and the find S algorithm. So first let's talk about hypothesis space. This is the set of all possible hypotheses that a learning algorithm can choose from. Think of it all as all the possible rules or modules your algorithm might consider. Second is find S algorithm. Find S starts with the most specific hypothesis and make it more general as it encounter positive examples. Based on the card data set in the question, after applying find S, we get the final hypothesis and the values are in our PPT screen. This is the most specific rule that matches all positive training examples. This is all about the question number 2. Now let's look about to question number 3, in which we we need to we learn about training, validation, test set plus cross validation. So first look training set. It is used to train the model. It learns patterns from this data. Second is validation set. It uses to tune hyperparameters and select the best module. And third is test set. It used to check the final performance on unseen data. Fourth is cross validation. Instead of a single validation split, the data is dividing into k folds. Each fold gets done as the validation set. This method is very useful for reduces overfitting and gives more reliable accuracy and uses data more efficiently. Cross validation is generally better than a simple train test split. This is all about question number 3. Now let's see question number 4, in which we learn about confusion matrix and evolution matrix. So we are given some values in question number 4, which are true positive is 6, false negative is 4, false positive 2 and true negative 8. From this we calculate accuracy, precision, recall, specificity, F1 score, type 1 error, type 2 error, whose values are accuracy 70% come, precision 75%, recall 60%, specificity 80%, F1 score about 66.7%, type 1 error 20%, and type 2 error 40%. So we all have one same question, why is this important? Because in real world scenarios, many accuracy alone can be misleading. For example, In medical tests, missing any positive cases is dangerous. So we focus on recoil. In spam filters, false alarm, hurt user experience. We focus on precision. So this is all about question number 4. Now let's look to question number 5, in which we will learn about dimensionality reduction and its feature selection and extraction. So why we reduce dimensions? Because to avoid overfitting. It is one of the main reason to remove dimensions. Second is to reduce computation time. Third is to remove noise. Fourth is to deal with the curse of dimensionality. And fifth is to make data easier to visualize. And there are two main approaches of it. First is feature selection, in which selecting the most important original features is important. Its examples are LASSO or L1, RFE, mutual information, decision tree importance, etc. Our second method is two features extraction. Create in it creating a new lower dimensional features from existing ones. Its example are PCA, LDA, autoencoders, etc. Feature selection keeps the original meaning of the data, and feature extraction creates the powerful new feature but loses direct interpretability. This is all about question number 5. Now let's look to question number 6. Hello. So in this co so So in question number 6, we need to explain overfitting and underfitting. So first, let's talk about overfitting. This happens when a model learns the training data too well, including noise and random patterns. It performs extremely well on the training set, but poorly on new data. Means we test with a low data size, and when we test on a large data side, it does not perform the same. Its science, very low training error and high validation test error. Now all have same question how to avoid it. So to avoid it, the first method is to reduce model complexity. Second, use regularization L1 and L2. Third, use dropout in neural networks. Fourth, get more data and larger sample. Fifth, early stopping. And sixth, cross validation of the data. Now, now let's talk about the underfitting. Here the model is too simple and fails to capture underlying patterns. Means on the test also it not perform very well as when the training. Its signs are high training error and high test error. And how to fix it. So to fix it, use a more flexible model, add more features, reduce regularization and increase training time. So in short, overfitting model learns too much and underfitting model learns too little. Now let's talk about question number 7. In question number 7, we need to compare, we need to difference between logistic regression versus linear regression. So first, linear regression. It is used for predicting continuous value like salary, house prices, temperature, etc. In it, we use hypothesis, cost functions, and output of any real number. Second is logistic regression. In it, it is used for binary classification like spam versus not spam, disease versus not disease. And now we'll talk about gradient descent in both. Both algorithms use gradient descent to update parameters by minimizing the cost function. The only difference is the cost function itself. Linear regression means minimize square wave error and logistic regression means minimize log loss. Both are simple, fast and widely used in machine learning. This is all about question number 7. Now let's look about our next question, which is question number 9, which is one hot encoding on the given data set. We have data in data set fruits like apple, mango, orange, but computer don't understand text. So we convert each category into binary column. The final one hot code table becomes apple 100, mango 010, orange 001. This technique is used in machine learning when dealing with categorical variables. It helps model to understand categories without assuming any numerical order. So this is all about one hot encoding. Now our now let's look about our final question, which is 10. Why KNN is called lazy learning? So the answer is because it doesn't learn a model during training. There is no training phase. The algorithm simply stores the data. The real work happens during prediction, where it calculates distance to all the points. That's why KNN is simple, effective, but slow during prediction. So how KNN works? First KNN calculate distance from the query point to all training points. And second, pick the closest k neighbors. In third, for classification, take majority vote. And fourth, it do for regression, take the average of weight divided by value. So we have given table in which we need to predict missing weight from the table. For ID 11 with height 5.5 and age 38, nearest neighbor founds are ID 6, 5 and 4. We take their weight, which is 60, 72 and 59. Using k equal to 3, the predicted weight is 63.7 kg. KNN gives a simple, understandable and intuitive prediction. And this is the summary where you can see what we learn about today. So this is all about in our today's video. Thanks for watching, and if you love our video, please like, share and subscribe, and see you in the next video. Thanks for watching.